Hi students, in this video we're going to learn about derivative at IGCSE level. First of all, we need to understand definition of derivative. What is derivative? So we can call this as derivative or gradient function or differential coefficient in the short form. So basically, derivative by definition is nothing but a gradient function. In Algebra 2 in IGCSE, you have learned about the gradient of a curve. Basically, if we have to find gradient of a curve at a point, for example, in this case, the curve is this red one, and this is curve to this equation x squared minus 4x plus 1. So if you have to find gradient of this curve at this point, which is 3 minus 2. This point is basically 3, x is 3, y is minus 2. So what we do, we draw a tangent at this point, a line touching the curve at this point, and we try to find the rise by run. Rise is basically vertical height, like this one, and run is horizontal. Move down a little bit. So I take 2 points on this tangent line. Suppose this point is here. I call this as point P and this point as Q. I move from Q. I move horizontally. This is called as run. If I move right, it will be positive. If I move left, it will be negative. That's called run, horizontal movement. Now after that, I'm gonna move up because I have to approach that point P. So when I start turning from here, moving up, that's called vertical movement or rise. So rise is nothing but vertical movement. Again, if you move up, it will be positive. If you move down, it will be negative. Now you can see clearly here. What is the run? Because we are moving horizontally rightward, it is positive. So we moved like 3 boxes. One box is 1 unit. So it is 3. So the run is 3. How much is rise? 1, 2, 3, 4, 5, 6. So rise is 6. Then what's the gradient of the tangent at this point, the curve? This point 3, negative 2. It is basically rise by run, which is 6 by 3 equal to 2. So that's the gradient. This 2 is positive, so that means tangent is rising up. Now we have a other way to find gradient of the tangent to the point by derivative. It's a bit easier. We don't need to draw the tangent and locating the point and doing rise by run, measuring the scales. It's a bit tedious, or maybe it's not tedious, it's about a longer way. So we got a short way here in terms of derivative or gradient function. Derivative, basically we denote by this operator ddx, means derivative with respect to x of function f or y. Normally if you write equation like here, in this case y equal x squared minus 4x plus 1, we can write it like this also. Fx is equal to x squared minus 4x plus 1. So we find derivative of this function y. So this derivative is d dx. By standard norms, we write like this: d dx of y if function is y, and if function is f, we write like f dash x. And both things are same. They are same, and that's called as derivative of a function or an equation or a polynomial. So by definition, what is derivative? Derivative is a gradient function. It's a gradient function. So derivative gives gradient of a tangent, in this case the blue line. Derivative gives gradient of a tangent, in this case blue line, at a point on the graph of that function. In simple words, for this function or equation, graph is the red one. At particular point 3 minus 2, we find the gradient of the tangent. We draw a tangent at this point 3 minus 2, then we find gradient by rise by run. So that value will nothing else but derivative. So simple word, derivative is gradient of a tangent. Derivative is gradient of a tangent. That's it. After knowing this thing, that derivative is a gradient of a tangent, we need to understand that if this is x-axis and y-axis, these are coordinate system, x-axis and y-axis, and this is origin. If I draw a line horizontal, definitely any horizontal line is parallel to x-axis, and the gradient of that line will be 0. It means derivative will be also 0. So derivative of all horizontal lines will be 0. What is the equation of horizontal line? If this point is 1, this line is y equal to 1. If this point is 2, this line is y equal to. So any horizontal line should have equation like y equal to a constant. So from here we understand that derivative of a function which is equal to constant value is 0. So rule number 1, please note down that derivative of any constant, C stand for constant, is 0, because constant give you horizontal graph and the gradient of all horizontal lines is 0. Rule number 2 is exponent or power rule. If you find any algebraic function or polynomial, we can find derivative of individual terms by using this power or exponent rule. What's that? If the function is y equal x power n, derivative, which is d dx of this function, will be the power comes in front as a multiplier of x raised to power the existing power reduced by 1. We write the predecessor of that power. Example, if I take x equal to 5, derivative of x power 5 by power rule will be exponent comes in front of x and exponent reduced by 1, 5 minus 1, which is 5x power 4. One more example, if I try to find derivative of x power minus 7, now the exponent is minus 7, it comes in front as a multiplier, and x power minus 7 minus 1 reduced by 1, not plus 1. So it becomes minus 7x power minus 8. That's it. So at IG level, to find any kind of derivative, you need to understand and you need to memorize two ways. That one is derivative of any constant. Derivative of any constant, that constant can be pi, that constant can be a fraction, 3 by 7, that constant can be a square root or the cube root, can be anything, any constant value. Derivative of any constant is 0, and by power rule we can find derivative of any rational or any polynomial expression in terms of power. So x power n is nx power n minus 1. So after understanding the concept, let's try some question from IGCSE book, Extended Maths. So this is one question. Our target is to find derivative. Derivative means gradient function. So because function is fx here in this case, I should not write d dx. I should not write d dx. The better is f dash x. Basically it is d dx of y, because and fx is y. Fx is nothing but y, right? So f dash x is basically, now this is coefficient of x power 5. I keep it like this one, 6. Now I apply power rule in this term x power 5. 5 comes in front of x as a multiplier and reduced by 1. Power reduced by 1. 5 minus 1. Likewise 4 here as a coefficient. So this 4 power comes in front of an existing power reduced by 1. Now this is a constant. We learned by first rule, derivative of any constant is 0. Just write a 0. Simple. After simplification, it becomes 30 x power 4 minus 16 x power 3. So that's the answer. We found out derivative of that given function. It is this one, and this is nothing but a gradient function. It's a function, it's not a gradient value. In the next questions, we're going to learn about the gradient values also, okay? Let's do one more example. Now in this case, we are given y as a function. So we should not write here f dash x because function is denoted by y. So we should write d dx of y. 1 by 14 is coefficient. We write like this, 1 by 14. Applying power rule, 7 comes in front, reduce power by 1. 7 minus 1. Minus 5 by 6, coefficient. 6 comes in front, reduced by 1. Power reduced by 1. Plus 1 by 4 as a coefficient. 3 comes in front and power reduced by 1. After simplification, we get answer here. So what is this now? 7 cancel. So this is 1/2 of x power 6. 6 cancelled. Minus 5x power 5. And 3 into 1 by 4 is 3 by 4 x squared. That's the answer to this question. So again, dy dx or ddx of y is gradient function to that curve, which is y equal to this one. Now last example to understand further. Here is something different. He's asking us to find gradient function, then the value of the gradient at these particular points. Method is same. This is fx. I'm gonna write like f dash x. So f dash x is equal to, now 6 into 2, because 6 is coefficient, power comes in front, which is 2, into reduced power, 2 minus 1. Plus 8, next term, is a coefficient, x power 3. 3 comes in front, power reduced by 1, it is 3 minus 1, minus 7, x power 1. 1 comes in front and power reduced by 1, 1 minus 1. Further simplification, 12x plus 24x square minus 7x power 0. Something power 0 is 1. So this thing is 1. 1 times 7, it becomes 12x plus 24x square minus 7 into 1 is 7. So this is gradient function, but not gradient at a point. So by using this gradient function, we're gonna evaluate values of the curve, value of gradient to the curve at different points. A part, he said that find a gradient at point x equal to 3. So now using this gradient function, we're gonna find value, particular value of the gradient. Just plug in x equal to 3 in this expression. We can write like this, f dash 3. This is 12 times 3 plus 24 times 3 squared. By using calculator, answer will be 24 into 3 squared. 12 times 3 plus 24 into 3 square. Answer is 252. B part. So B part, we'll find gradient of the curve at point x equal to minus 4. We write x equal to minus 4. That means f dash minus 4 will be 12 times minus 4 plus 24 times minus 1 square minus 7. Oh, I did mistake, sorry. So basically in the previous question I forgot to plug in to write that negative 7. So it must be negative 7 equal to, let's check again now. So 12 times 3 plus 24 into 3 square minus 7. So minus 7 must be 245. That's the answer to the first part. Now in the second part, we have f dash minus 4. It is 12 times minus 4 plus 24 times minus 4 whole square minus 7. So answer is 329. C part. In the C part, we had to find out gradient at point x equal to 2 by 3. So at x equal to 2 by 3, it will be f dash 2 by 3, which is, because f dash x is 12x, it is 12 times x is 2 by 3 plus 24x squared, which will be times 2 by 3 whole squared, negative 7. Let's use calculator fastly. 12 times 2 by 3 plus 24 times 2 by 3 whole square minus 7, and answer is 35 by 3, or change to decimal 11.6 dot. Alright guys, so this is the way how we can find a particular value of gradient at a point by just using the gradient function as a derivative. So I hope you guys understand. Thanks for watching. Take care.